Okay, well, thanks everybody for joining us today for our webinar called Reducing Embodied Carbon from the Industrial Sector, Business Voices on the Role of Federal Procurement. I'm Verena Radulovic. I'm Vice President of Business Engagement at the Center for Climate and Energy Solutions. In case you don't know us, C2ES is a nonpartisan, nonprofit research organization, and we're committed to advancing climate solutions and the technologies and policies that promote them. We do this by catalyzing business action through our Business Environmental Leadership Council, which is a group of Fortune 500 companies committed to addressing climate change. We also do this by bringing together stakeholders of different perspectives in different sectors to build common ground. And you may know this through our Climate Innovation 2050 initiative. If not, you can check it out at www.c2es.org. Today, we're going to look at the role of government procurement in reducing emissions in the industrial sector. And we're going to do that by examining lessons learned and insights from companies themselves. As many of you may know, the industrial sector is responsible for 23% of US greenhouse gas emissions. And without serious emissions reductions efforts, this number is expected to grow by 15% by 2030. So a large number of industrial emissions can be traced to the embodied emissions, the way that these products are manufactured, to a group of commonly sourced industrial products. They include cement, glass, steel, aluminum, and a lot of chemically based materials. And so while reducing the process emissions and then replacing the thermal energy that is used to make these products with clean energy sources are some of the more effective decarbonization strategies, these strategies are often really hard to do because they're cost prohibitive. So creating demand for these low carbon materials and the different ways that they can be made is an effective way to spur investment in the sector from the companies themselves. Previously, over the last 15, 20 years, we've seen how federal procurement specifically, and then state and local procurement, has successfully strengthened demand for more sustainable goods and services. And we see this, and maybe I'm using my own experience, is most notably in the energy efficiency products of the Energy Star program, which is a requirement by the federal government. If we shift over and think about greenhouse gas emissions in the manufacturing phase, these emissions are significant in the manufacture of key products and materials. The federal government could actually play a similar role in accelerating the markets for these lower carbon goods. So today we're going to look at specifically materials used in the built environment. So if this looks like a buildings material webinar, it is, but really the lens, it's really the example that we're using to talk more concretely, pun intended, about the way to reduce embodied emissions. So these principles can be applied to other goods and services. So first, we're going to hear from the U.S. General Services Administration, more commonly known as GSA, which owns and manages the federal government's buildings, and it is the federal government's purchasing agent by connecting purchasers to commercial products and services. But specifically within GSA, we're going to hear perspectives from the Federal High Performance Green Buildings Program on their perspective for what it would take to reduce emissions from materials in the built environment and their experiences in the built environment sector. Then we're going to shift to a discussion with examples of how the private sector is using procurement to reduce the carbon footprints of the materials that they're using. And these are the materials that have high embodied greenhouse gas emissions. And again, when I say high embodied greenhouse gas emissions, for those newer to this work, it's, that in the manufacturing phase of making the products, there's a lot of emissions that come either through being emitted as process emissions or in the fuel sources that are used to make the products. So companies will look at how, and we're going to ask companies that are our guests, which I'll introduce here in just a moment, how federal government procurement specifically can unlock greater potential for investment and market uptake, because the federal government is one of the largest purchasers in the US economy of many of these goods and services. A few housekeeping items. There will be opportunities for audience members to ask questions throughout the webinar. So we'd like this to be a dynamic conversation. I'm going to be doing 10 things at once, one of them being looking at people's questions as they come in. So please do send them in and we'll do our best to address them throughout the discussion. We are recording this webinar, so it will be available on our website and our YouTube site in a few days. So with that, I'd like to introduce our panel. First with us, we have Donald Horn, who is the Deputy Director of the Office of Federal High Performance Green Buildings in the US GSA. We will then be, after we hear from Don, they're going to move over to Leo Barrera, who is the Director of Public Policy and Government at Lafarge Holcim, which is a very large multinational cement company. Stacey Smedley is going to then speak. She is the executive director of a new organization, a new nonprofit called Building Transparency that provides open access data and tools necessary to help the building sector reduce its embodied emissions. She's also the co-creator of the Embodied Carbon and Construction Calculator, EC3 tool that she's going to talk about. And then we are joined by Sarah King, who is the sustainability director for Skanska USA Commercial Development. Really excited to have this group of people here. These are all people who are deeply knowledgeable about the building sector and can shift to a conversation around the embodied emissions there. So we'll start with Dawn. Dawn, I'm going to start with you to share with us your office's perspective on advancing materials made with lower embodied emissions.
Okay, thanks, Verena. So hopefully everyone knows, but just in case, GSA provides centralized procurement to support the rest of the federal government. We manage a nationwide real estate portfolio of nearly 370 million rentable square feet and oversee approximately $75 billion in annual contracts. GSA's mission is to deliver the best value in real estate, acquisition, and technology services across the government in support of the administration's priorities, one of which currently is climate. So one of President Biden's first executive actions in January was issuing Executive Order 14008, tackling the climate crisis at home and abroad. This particular executive order sets out the administration's commitment to climate action. Among other items, it requires a comprehensive plan for the government to create good jobs and stimulate clean energy industries by revitalizing the federal government's sustainability efforts. It also requires each agency to create a climate action plan. So GSA calls its plan the Climate Risk Management Plan, and hopefully this is going to be released next week. We're waiting for Council on Environmental Quality, but hopefully all the agency climate action plans will be released next week. And ours includes steps GSA will take to make its mission, operations, and assets climate ready. Through our plan, GSA seeks to lead by example to reduce emissions and decarbonize the federal footprint, as well as making our facilities and supply chains more resilient to a changing climate. We do this by partnering with our customer agencies and working with suppliers to ensure delivery of critical products and services. By adopting commercial practices for managing supply chain emissions through supplier engagement, we can encourage efficiency and reduce costs and risks for both agencies and industry alike. Our desire is to leverage our purchasing power to cut carbon emissions and save taxpayer dollars. We know this is good business practice from our previous experiences with sustainability. When we can show that we're saving money, this is when practices become embedded in the organization and carry on through continuing administrations or other issues. Requiring contractors to consider their carbon footprint provides protection against risks of higher energy prices and climate change. One of our actions is to ask our largest contractors to report their greenhouse gas emissions. So since 2015, GSA has asked around 300 contractors to voluntarily report GHG and their targets and climate risks through the CDP. In most recent disclosures just completed this summer, we're seeing an uptick in the number of companies using CDP, as well as an increase in their GHG reduction targets. Many more companies are setting and committing to set aggressive targets that are validated through Science-Based Targets Initiative. But at the same time, GSA seeks to understand the full impacts of carbon disclosure. There are many nuances here. We need to avoid requirements that would limit competition or disadvantage small businesses. So it's really a careful balance for us to understand how we can be effective with this. We've learned over the past year that the supply chain is fragile. There is great concern for risks and costs from changes in the supply chain, and we need to work on making the supply chain more robust. Another executive order, 14030, climate-related financial risk, was issued in May, and it has new requirements that direct the opening of 2 FAR cases. One of these would require major federal suppliers to disclose climate risk and GHG emissions and set science-based GHG targets. The other would direct agencies to minimize the risk of climate change and consider the social cost of greenhouse gas emissions, including embodied carbon, in major procurement decisions, and give preference to proposals with a lower social cost of greenhouse gas emissions. So I'm really looking forward to see how that plays out. The administration will be releasing more details on these FAR cases as the regulatory process progresses, but currently we don't have any specifics on that. So GSA is also working to incorporate embodied carbon reduction in our building projects. And this is what I work most closely with. You have a Green Building Advisory Committee that of private sector experts and government others from the federal government that provide recommendations and advice to GSA on issues we should be pursuing. In February of this year, they issued recommendations for reduction of embodied carbon in federal construction projects. There are basically two recommendations that the letter ended up emphasizing. One was using materials in building projects whose product emissions fall within the best performing 80%, as demonstrated through environmental product declarations. So basically requiring environmental product declarations for 75% of all the materials that go into our projects. The second recommendation was using a whole building life cycle assessment approach for larger projects or new construction projects to show that the life cycle carbon assessment results in a 20% carbon reduction compared to a baseline building. So these recommendations sounded good, but there's a lot of nuances to be worked out. And so we hosted an embodied carbon roundtable in June of this year with more than 50 industry and government experts to determine more specific strategies for implementation and what else we could be considering beyond this. Some of the highlights, they re-emphasize the value of looking at 75% or requiring 75% of all products in our projects to have or supply us with EPDs. This will help build the market, but then there are still questions about that. We need to set parameters around how and where they are appropriate. Are we looking at 75% of all products or 75% of the products within a particular category, or 75% of those with the largest environmental carbon footprint, or 75% of the highest volume of purchase for GSA? So those are some of the things we have to still work out, but there was a lot of good information to consider there. They also reemphasized the whole building life cycle assessment approach, and to start this as early as possible in the design process to optimize the impact. But as we think about that, we need to develop guidance. We need clear guidance on how to create the whole building LCA, what tools to use, the scope to include, and what we would be expecting to have valid, usable results for GSA. Another item that came up was the real importance of looking at embodied carbon and asset planning and how we can use this to evaluate the trade-off between new construction and reusing existing buildings. So if we include the time cost of carbon in asset planning decisions or social cost of carbon, then that will raise the importance of reusing existing or historic buildings. Approximately 1/3 of our inventory is in historic buildings currently. A couple other topics. One was refrigerant selection and leakage, to really look at the impacts from that and the new generation refrigerants. We discovered from our GHG reporting last year that 14% of our scope 1 emissions are from fugitive emissions. So that's an important consideration for us to work on reducing that. Another really important thing here is embodied carbon education, that we need to host education sessions for both GSA and the broader industry to explain our approach and what we are expecting in terms of embodied carbon reduction. And so that's something we're already starting to do. So if we do put requirements in procurements so that all of the offers are on the same page and understanding why we're doing this and what exactly we're looking for. There was a recommendation that we require participation in the Energy Star for Plants program. So EPA is still developing that. I know that several industries are included currently, but there aren't a lot of plants participating in some of the areas. And so if we were to require that, that would really give a boost to that program. It could be something as simple as requiring a score of at least 50 for participation in government contracts. But that's still to be determined, of course. And then looking at construction processes and what happens on site with idling of vehicles and transportation and delivery of items to a construction site and all the embodied impacts of that. So GSA is currently still evaluating these recommendations to develop specific actions and policies. We have actually like 3 meetings later this week to look at some of these issues. So it's actively one of our top priorities, and we will have more information moving forward in the future here. We are also hoping within the Public Building Service to have a performance measure for embodied carbon reduction starting in fiscal year 22. So those are a few of the things that GSA is looking at and thinking about, and I will turn it back to Verena.
A little slow on the uptake here with the video. John, thank you very much for all of this comprehensive information. Just kind of seeing some of the questions that are coming in. I guess my main question though, given that there's so much that's going on, and it's really exciting to see that GSA is considering all these different ways that they can incentivize suppliers to take steps to make reductions. Is there something that are there partnerships, or are there ways that you think are really important for industry to also kind of provide the insights and the information that GSA would need? Or do you feel that there's enough information that's already out there, and it's more of a matter of figuring out how to approach the supply chain?
Yeah, it's an interesting question. I think it's a two-way dialogue here, and that's what we've been trying to do. So we need to learn from industry what they are doing and what works for them, as well as setting our own targets and requirements so that we can actually push. With some of the other groups I've been involved in, I understand how industry is protecting their own interests sometimes and trying to say, oh, you know, don't pick on us, go look at all the others as well. But, you know, we want to really have an impact and see where we can have the biggest impact. And sometimes that's going to be in alignment, sometimes it won't. But I think we need to learn from each other in determining what the best steps would be for us to implement.
Got it. Are there certain industries or certain materials within the built environment that you feel are further along than in others? Or are we looking kind of more comprehensively at a wide range of sectors?
Yeah, I definitely think there's some that are further along. I mean, concrete's the one that everyone's kind of focusing on because you have a lot of buy clean policies already out there with certain limits and things stipulated for concrete, but yet there's still a lot of gaps there as well. So I think the structural materials are what everyone has focused on so far. Those are the largest impact in general. I think as we start to inventory what are the common materials that we're using in our buildings and in our even in our smaller tenant fit out projects, then to see among those interior finishes and others, what are the largest, again, carbon footprint that we could focus on and try to tackle next. So, yeah.
I do see one question that I think, and if there isn't enough information on this yet, we can tackle this another time. But I did think it was interesting that the social cost of carbon was mentioned as something that could be potentially considered in procurement, which is a creative way to approach incentivizing a reduction in, or at least signaling where you might have a reduction of embodied emissions. Can you speak to anything more that you know about that, or is that still under development?
Well, yeah, so there's nothing specific, but it is something that GSA has talked about for a number of years now. And it's really trying to figure out what is the best way, a valid way of incorporating that into a decision making. From what I understand, OMB sets the social cost of carbon for the government every year. So we have a value that can be used, but how do we factor that in? And we wouldn't, I can't foresee GSA switching, all of a sudden, but what my recommendation would be is to have both evaluation methods currently, using the first cost and other things that are typical, but then also doing another parallel evaluation with social cost of carbon or the embodied carbon total cost, and then seeing how those two play together and how it might influence decisions, and bring that in slowly until people are familiar with it and see the value in it. And then I think it could take off as a much more robust approach for selecting which projects to move forward.
Great. I've got one last question for you, Don, and then we're gonna let you go or let you go off to the side and take on the other panelists. But there's been, over the many years, there's been a lot of work being done to sort of improve the energy efficiency of buildings and kind of thinking through how buildings are run. And as we move into a conversation around the actual materials that are in the building and reducing those embodied emissions, do you think that there are any applicable lessons learned that are kind of apply from one to the other? Or are we really looking at a new set of stakeholders, actors, decision makers, kind of trying to think through how to capitalize on all of the successes in the past as we kind of venture into the embodied carbon space?
Yeah, it's an interesting question. I hadn't thought of that perspective, but I can see some similarities, but others, it's a whole different set of players. It is, different ways to think about reducing embodied carbon. There's the procurement side, but then there's also the design side, and optimizing the building and the systems and whatever. And so that would be very similar to the other sustainability and energy efficiency practices and strategies that we've done before. But I think when we get to the procurement side, it's a very different focus, and it's bringing in different players with contracting officers and others. So yeah, there's some similarities, but it's a new game for us as well.
Okay. Don, thank you so much. We'll bring you back if others have questions, or if you'd like to jump into the discussion. But for now, we're going to switch over to Leo Barrera, who is from LafargeHolcim, and is going to kind of walk us through the first part of the supply chain, which is the development of the primary materials. So we'll go ahead and there we go. Thanks, Leo.
Thank you, Verena. It's great to be here with you all, and thank you, Don, for putting out kind of GSA's view on this. To all of you who don't know LafargeHolcim, we're a global building materials company with operations in over 80 states, 80 countries. In the United States, we have operations in over 40 states. We're about 9,000 employees strong. We have the distinction of being the largest cement producer in the United States, as well as one of the leading suppliers of ready-mix concrete, asphalt, and now the largest supplier of green roofing materials in the country. So we like to tell folks that we build everything from the foundation of your house to the roof. Next slide, please. I like to start by walking folks through an overview of the construction process. This is a little bit simplified diagram, but it starts with the client, who's the head of the procurement chain. The client owner influences what is to be constructed, where, when, and by whom. Oftentimes, a client will use a consultant, sometimes a sustainability consultant, sometimes a consultant for that specific type of build. If you're thinking, if you're building a data center or something that requires specialty design, you'll hire a consultant in addition to your architect and engineer. Together, the client, the consultant, the architect and engineer, oftentimes I like to call them design team, will have tremendous influence on establishing performance requirements, the specifications of materials to be used, and even the suppliers. Ultimately, they end up selecting a contractor who then selects subcontractors based on capability, product availability, and price. They interpret the design elements of the client owner, the consultants, the architect, and an engineer. And then they work with the subcontractors to make the building happen. LafargeHolcim will often find itself at the end of that supply chain over here as a subcontractor, providing building materials, providing cement and concrete to a contractor that then goes on to do a building job. For major constructions, we'll sometimes find ourselves playing a role as a consultant as well as a subcontractor, because we have the in-house expertise to provide design efficiencies, suggestions, given our large history of manufacturing cement and concrete and having the world's largest research and development center for cement and concrete in the world. Next slide. This is the same slide, but it shows how the government plays such a significant role in the selection of materials, and oftentimes may limit the ability of the contractor and the subcontractor to use new innovative building materials. Because the government can be all three: the client, the consultant, and the architect and engineer. So by the time the building design gets to the contractor, the materials have been so highly specified that the contractor or the subcontractor won't have the ability to say, hey, we have new innovative building materials that can lower your carbon footprint without having to go through 3 layers of government bureaucracy. But it also provides a unique advantage to the government because the decisions that they make will have such a large impact in the industry. And I'll highlight here in a second why. Next slide, please. I think it comes to no surprise to anyone on this panel. If you've been following carbon emissions in industry, you know that carbon emissions, that cement manufacturing is a carbon intensive, energy intensive process. We are working every day at LafargeHolcim to try to come up with new innovative ways of reducing our carbon footprint. And I like to think that we've made significant progress. We are now on the leading edge of deploying 1CEM, low carbon cement, low carbon concrete. So the technologies to reduce our carbon footprint are here. The biggest challenge we're going to see is deploying them. In terms of a typical carbon impact during construction, you want to reduce the embodied carbon of a building, you have to tackle its concrete. That represents about 73% of the total carbon emissions of a construction of a typical building. Here's where we see Buy Clean policy come into place. Next slide, please. Thank you. Buy Clean is not a new concept. It has been around for a number of years, and I wish I could take credit for it, but honestly, the good folks at the Blue Green Alliance and a lot of the Carbon Leadership Forum and a lot of folks have been doing a lot of good work on this policy way before I joined the group. But it has been gaining traction. It has been gaining traction at the federal level, state, and local level. As we can see with this updated map, with action just occurring earlier this year in Colorado, being the latest state to adopt a Buy Clean policy. Next slide. So just a quick refresher of what Buy Clean policy is. It's a 3-pronged policy approach that starts with disclosure, that is requiring individual product-specific EPDs to be submitted at the time of the bid to compare equal materials. Then it goes on to set a standard based on performance, and then using that standard to drive the reduction in carbon emissions. And lastly, Buy Clean policies will oftentimes provide incentives to increase participation in the Buy Clean program to help producers transition from older technology to new technology, or just reward innovators and industry leaders to continue pushing low carbon solutions. Let's take that and put it into practice. Next slide, please. Here you'll actually see 2 EPDs that we developed for our products here at LafargeHolcim. These are on the bottom part. First, for all those that don't know an EPD, this is what it looks like. It's very similar to the nutrition label on your cereal box. It will highlight information such as the global warming potential, as well as the total waste and consumption of fresh water and other important environmental indicators. But oftentimes the benchmark is set about using global warming potential, or GWP. If we take 2 blends of concrete, a traditional type 1 concrete, it has a global warming potential out of our Fort Totten DC plant of 508 kilograms for CO2 equivalent. If you use EcoPack, our low carbon concrete, you can get that reduction down to 216. In a typical building, we modeled this for a data center build, actually, you could reduce carbon emissions by 53%, and that's roughly the equivalent amount of CO2 that it would take to power 450 homes for a year. Next slide, please. Why is this so important for the federal government and governments writ large? I think this slide says it all. If you look at the overall use of cement, you'll see that over 40%, nearly 46% of it goes to public works, public infrastructure, buildings, highways, streets, sewers, wastewater, military installations. So when the government, who is the owner, the architect, the consultant, when they change their procurement parameters, it will have a significant impact in our industry. And we've seen this from experience. The government of Canada made the decision that they were only going to procure low carbon cement, and over time, all operations in Canada, and the only thing you can buy today in Canada is low carbon cement. So we're very optimistic that working with Congress and working with the administration, we're going to be able to implement policies that help reducing embodied carbon in the built environment, and at the same time create a little competition and transparency in the building materials industry. I think as our presenters will talk here shortly, having these EPDs are a very powerful tool, and they will provide a good incentive for the industry to continue to compete and continue to reduce our carbon emission footprints. And with that, I'll pause over for questions or wait until the end, whatever you decide, Marina.
Let's see. Let's take questions at the end when everyone's kind of presented, just because that might kind of give a oh, actually no, we have a couple questions that have come in, so I will take two. When we look at and I think this is a question that Don had alluded to earlier, when we look at kind of the development of EPDs. For Lafarge-Holcim, are the EPDs facility specific? Like how long does it take to typically produce an EPD?
Yeah, so I think EPDs have been around for a long time, and they were traditionally used as an industry benchmark. So a lot of individuals will have an EPD, but it will be an industry-wide EPD. We made the decision last year to move to product-specific EPDs, and each operation will be different. To get a third-party validated EPD certificate, you usually need about 1 year's worth of data, production data, submitted to the third party.
So you're doing it from a product, not just a plant.
So we did individual EPDs for our 13 cement plants across the United States, and then we're doing EPDs for our individual ready-mix concrete blends across. I think we're 100% complete in the Mid-Atlantic region, and we're slowly moving our way through other regions in our operational footprint.
Got it. Okay, great. That actually, I think, segues really nicely to Stacy's presentation on the EC3 tool, which is all about how to use EPDs. Hold on, let me go ahead and join you here for a moment, Leo. Okay, there we go. All right, Leo, thank you so much. With now, I'd like to turn over to Stacy and to have her walk us through the EC3 tool.
Great, thanks. I'm going to go ahead and share my screen. I'm going to do a few slides and then jump into a demo of the tool. So I appreciate the ability to share. So I'm going to talk today wearing my building transparency hat. I'm currently the executive director of building transparency, but also a sustainability director at Skanska USA Building, one of the largest general contractors here in the US, and really talk through how we're supporting embodied carbon reduction through digital data transparency and the EC3 tool. Just a little bit about our nonprofit that Rena mentioned. It is a new nonprofit established in 2020 to support the continued scaling and management of the free open access EC3 tool and other free open access data that's necessary to really tackle embodied carbon emissions of the construction industry. We're currently supported by a kind of a cross section of the industry. So we have philanthropic funding from Breakthrough Energy, who's funding a lot of these low carbon material products and sees a tool as a way to incentivize their adoption. We have owners like Microsoft, Amazon, and Google. We have architects like Perkins & Will and ZGF, engineers and contractors that you see on the screen, as well as material industry organizations and manufacturers that are very keenly interested in how the data is displayed in the EC3 tool and really want to partner on getting their industry organizations and materials populated with EPDs in EC3. Just briefly, I typically use this slide when I'm talking about these emissions because we are talking about manufacturing emissions of the key materials that we use to make construction products, particularly, as mentioned, cement and steel, which are a large component of these greenhouse gas emissions for manufacturing, as well as chemicals and where a lot of the other construction materials live. And it's, of course, because we now realize that embodied carbon emissions of the built environment account for more than 50% typically now if we're looking at zero carbon targets of 2040 to 2050. We're building a lot and we need to reduce these emissions as quickly as we can. You saw some of the touch points on public policy. We tend to think of things through the lens of policy on both the private side and the public side. Those policies can be aligned and the same, and that's what sends the biggest market signal. So our large corporate partners that are looking at this are setting zero carbon targets, including their supply chain emissions, and trying to come up with those policies that they can put in their procurement language that maps very, very similarly to Buy Clean language on the public side. And as Leo mentioned, there's also Buy Clean policies that we're supporting through EC3, where we have compliance filters that enable the searching and sorting of the data through EPDs within the tool to meet different compliance requirements as these legislations pop up. And there's also language being proposed in federal policies like the Clean Future Act and other avenues like the GSA, where the same kind of language is being specified and proposed. So the question is, how do we actually support all of those policies and enable adoption of EPDs and disclosure, as well as reduction? EC3 understands, building transparency understands there's all these different life cycle stages of products and building emissions when it comes to embodied carbon. The EC3 tool is keenly focused on the product emission stage to date in that procurement lens, because that's where 50 to 70% of the emissions can be, depending on the product, maybe even more than that for the higher emitting manufacturing processes. EC3 is a free tool, so it's available for free on the website. I'll get into that in a second, in a very quick demo. And it's also transparent in terms of the data and how we're assessing it. And it's been informed by all of those partners that you saw on the screen. You heard life cycle assessment in Dawn's presentation. We also need to make the point that EC3 is trying to fill the gap in this kind of procurement by clean EPD category. LCA is still very important to use average emissions factors to look at your whole building reductions in terms of optimization of materials. Once you know what you're building out of is when you can use EC3 and EPDs to really source the lowest carbon options per material category. What EC3 does is allows you to do a find and compare materials search of the EPD database that we've digitized. So we've crowdsourced all of the EPDs currently available and published and turned them into digital documents that can then be searched and queried to enable sorts and filtering. And then also a project level where you can take quantities of materials from construction estimates or BIM models and multiply them by these carbon intensity factors of the products that you're using or proposing. And again, we're digitizing these EPDs, keenly focused on the global warming potential per unit right now, with plans to expand to other impacts over time. And the idea, I think, mapping to ASHRAE is that as we start to incentivize lower carbon materials and competition, there can be benchmarks that are set that then lower as we get better at optimizing materials from a carbon perspective. Then very, very quickly, because I know we have a lot of presenters, I just want to walk through the tool just so you can see it in action. You can register for free at the website buildingtransparency.org to gain access yourself. A policymaker or a contractor or a designer can go into the tool, understand where we're having EPDs globally into the database. For concretes, as Leo mentioned, we have an on-demand EPD integration that allows ready-mix suppliers to create digital EPDs that translate directly into the tool. And that was really led here in North America. So you can see the number of concrete EPDs that we now have. And if you go through these slides, you can see kind of how that spreads across the country. I feel like every time I look at the concrete slide, we're seeing more little pockets of blue pop up around urban areas where this information is being requested. In the tool, you can actually search and sort all the data. So I can go into ReadyMix. You can see all the categories that we have. You can sort by performance characteristics like strength. You can sort by geography. So if I pick Washington where I am, where I know we've got good adoption, I can now search for EPDs in Washington state. It's going to return all of the suppliers and products specific EPDs that we have in the tool. You can see we have 429. Each one of these is a digital EPD that gives you the manufacturer, the plant, the mix ID, the strength, and the carbon content per unit. And this compare feature is really what's been helping procurement understand who has EPDs, what level of adoption we have, what their ranges of carbon content are for their mixes, and where could limits or benchmarks be set that enables multiple bids. This also incentivizes the suppliers to reduce their carbon emissions. Very quickly on the building side, it's a similar thing where you can actually put in building information, your material descriptions and quantities, do those same searches to get to collections of data for your supply chain and who has EPDs, what are the ranges of carbon, actually select the EPDs you use, and get to some summary charts that enable you to actually see the relative impacts of the different material categories. So what is my concrete impact compared to my rebar, compared to aluminum, insulation, glass, etc.? What's the available reduction potential based on the EPDs in the supply chain at market? And then what did I do from a selected material standpoint during procurement? So all of this is what the EC3 tool is trying to make available to people. The last thing I would say, just from what we're seeing on the private sector side, is that there's just these steps that seem to be what steps are, whether or not it's private or public policy. It's requiring EPDs, asking for them if they don't exist. It's specifying products that have them during the specification process. It's bidding that into your bid documents, the request for EPDs or requirement. It's then using that data at bid leveling time to understand who's the lowest carbon option next to cost. And then it's actually realizing your savings and documenting that to get to an actual carbon content of your projects using EC3. Just a final note, the tool is getting broad adoption globally with over 16,000 users. We're seeing around 2,000 projects already in the tool to help us with benchmarking. And this is just an example of last year in the markets where we had concrete EPDs and used them. We saw about a 30% reduction from baseline at no cost premium using EPDs during procurement to incentivize carbon competition. Just an example in the Washington market where we've had 3 suppliers with EPDs for about a year now, where they've been required in large projects like the Microsoft Campus project. We've seen the whole collection of EPDs in terms of carbon content go down by upwards of 30% for the suppliers that are competing now on carbon and cost. So that's the reduction within the tool that you can start to track. That's really it. The one comment I wanted to make before we move on, I know that was a lot very quickly, but I could talk about this for hours, is just that we've done the math. And if we were able to achieve that 30% reduction for all US consumption of concrete and steel, that would be the equivalent to reducing 2 million cars on the road, or sorry, 14 million cars on the road, or decommissioning 16 coal-fired power plants. And that's really the potential of what this can do if we do it holistically across private and public procurement policy.
Nice. Thank you, Stacey. I do have a couple questions before we jump to Sarah, and this is, we'll get into the policy conversation in just a moment here. I think that we have a couple of folks that are listening in that have some questions about EPDs. With the EPDs, are they based on the public data, or do they also incorporate some of the proprietary data from companies? And then I guess the other question too is, you know, are the carbon content numbers for carbon sequestered, or is this all for all carbon produced pre-installation?
So in terms of the EPD data, they are based on life cycle assessments that do contain manufacturer proprietary data. So it's someone that's going in and getting the actual process emissions and energy consumption at a plant and using that information with the ingredient mix for a product to create a life cycle assessment of that product. It then gets verified and produced by a program operator into an EPD. There are some places where they use average factors for some of those inputs, and we're actually working with industry organizations to actually push transparency down the supply chain, things like concrete EPDs that have cement plant EPDs attached to them, which I'm sure Leo could talk about too. When it comes to what's included, it's really all driven per category by product category rules. Right now in the US for concretes, it's just the production stage. In Europe, they actually do include the full life cycle of concrete and the carbonation that can happen. So this gets into when we are thinking about federal policy, there should be something in there around coming up with a standard PCR language that the government would want manufacturers to follow when they're creating their APDs, so that you're comparing apples to apples and you've got what you want included in that procurement.
Very good. Thank you so much, Stacey. We'll get back to that in just a moment.
Yeah.
So then the next step we'll read to feature Sarah King, who's representing Skanska USA Commercial Development, and to hear kind of how a company is sort of taking all these different ingredients and actually trying to sort of make changes at the actual construction level. So Sarah.
Great. Thank you so much. It's good to be following great speakers, and I'll just try to pick up where we all have been taking the conversation, and we'll go from there. So I'm really bringing the perspective of a real estate developer and building owner and how we're working to reduce embodied carbon on our projects. Next slide. For anybody not familiar with Skanska, we are a global real estate development and construction company headquartered in Stockholm, Sweden. We have a presence across the Nordics, Central Europe, and the United States. The business unit that I represent is Skanska USA Commercial Development. So we're the owner developer arm. We're active in 5 US markets. Those are Washington, DC, Boston, Houston, Seattle, and Los Angeles. We're primarily from CDUS delivering commercial office and multifamily projects. Skanska has a long-term commitment to sustainability. On 100% of our CDUS projects, we do a minimum of LEED Gold, many achieve platinum. We have a global carbon target to achieve carbon neutrality by 2045. And that includes not just our own operations, but our value chain. So it's the operational carbon and the embodied carbon upstream. And we've got a 50% interim target in 2030. And there might be a couple more clicks here, but we could just go on to the next slide. So this picks up on, I think, what all of the panelists so far have talked about. So there's a lot in the value chain. So there's the operational carbon piece, which we've been focused on for many decades, and we will continue to be focused on. So this isn't an either or with embodied or operational, it's really an and. So, and there's the embodied carbon side, which is something that we really have we kind of have a one-time bite at the apple with the embodied carbon side. With the operational side, you can do retrofits, you can do upgrades over time in a building's lifetime to improve the operational energy efficiency, but you really just get one opportunity to make your material and supplier selections for the construction materials that you'll use to build that building. Next slide. So how I see it, there's a bunch of windows of opportunity to influence this embodied carbon. And knowing that we have a diverse group on the phone, you may see yourselves in one or more of these buckets, or there may be other opportunities that I hadn't thought about. The first one is just renovate. And I think this has come up already in the conversation, where you can use that existing structure again. That embodied carbon has already been spent. So it's a great carbon savings if you can reuse that existing structure. On the second side, the second opportunity is if you are doing new construction, this opportunity to think about the design phase. And I think Don spoke about this with whole building LCA, thinking about what you're going to build your building out of. Is it going to be a concrete and steel building? Are you going to incorporate timber kind of for your building type and size and location? What's the right mixture of materials to optimize and reduce embodied carbon? The third window of opportunity is once you decide what you're going to build your building out of, how are you going to go procure those materials? How are you going to select your suppliers from the market? And so this is really, how are you going to incorporate that carbon intensity alongside price and schedule and performance? And so this third stage is really where that EC3 tool is designed to function best. And then last but not least, there is the fit outs in the interior fit outs. So you might be thinking, well, I don't have control over a whole building. I'm not doing new construction, but you may be a tenant at a building. And so there's an opportunity if you are building out an interior space to think about as you procure carpet and ceiling tile and wallboard and paint and furniture. There's a lot of opportunities there also to reduce embodied carbon. So my perspective is I'm kind of focused mostly on those middle two areas around new construction, but I think that there's huge opportunities for probably everybody on the phone to think about where you could have an impact. And next slide. I wanted to share just a quick case study of a project in Bellevue, Washington, just outside of Seattle. So Skanska Commercial Development is using the EC3 tool, which we just heard about from Stacy, on all of our projects in the US. And so this is one example of a project that just recently started construction. It's an office tower, primarily steel and concrete. You can see the EC3 diagram, the Sankey diagram, that after we inputted all of our material quantities, this gave us that information about what parts of the building, and the materials have the biggest carbon impact. We really took a strong focus on the structure. So we really lasered in on concrete, structural steel, and rebar as the opportunities where we wanted to really see what we could do to move the market and reduce our embodied carbon. So ahead of our bid process, ahead of sending out that bid package to our suppliers, we worked closely with our structural engineer to update our concrete specifications to include some of those carbon intensity targets, a requirement for plant-specific EPDs, and then we sent that out to the market, got good bids back, and ultimately we're able to achieve a 50% reduction in embodied carbon when we look just at the concrete and rebar supplier selection. And so that was at largely no additional cost or impact to schedule, but it was just about being transparent and looking for that carbon intensity and factoring it in as we made that supplier selection, still considering cost, still considering schedule and performance. And so if you kind of think about all of the material categories for that whole core and shell, including the envelope and the structural steel, what we've been able to do to date is about a 30% reduction across all of those material scopes. And then last but not least, just kind of some lessons learned so far from my perspective. Number one, collaboration is key. So you're not going to be able to do this by yourself as an owner or a contractor. You really have to have a lot of collaboration. And then the structural engineer is a really critical player too. Number two, incremental progress is still progress. So it can be overwhelming to try to tackle an entire building and all the different material scopes and try to reduce embodied carbon in all of them. It's okay to just start with concrete or just start with rebar. In one of our markets in Houston, there weren't plant-specific EPDs for concrete. And so that was our real goal, was to, can we get one supplier to commit to do that? And we were recently able to do that, which was a big milestone for us. The third, inertia is real and timing matters. So this isn't rocket science, but it is adding a new factor to material procurement and the supplier selection process. That is something that construction companies are used to doing again and again. And it is a new thing and can be challenging to add something new to any process. And so I think, Stacy hinted at this, but it's important too to make sure that when you do get to that point where you've collected your bids, you've asked for this, you've done all this work, make sure that when you are leveling those bids, you're remembering to think about this carbon piece and incorporate it into your decision-making. And then the last one, demand shifts markets. And this is really where I think it's the biggest take-home lesson, and it's the biggest, I think, reason why we're all here today and why the federal government's role is so important. So the more voices that are asking for material suppliers to deliver these plant or mill specific EPDs, the better. More interest from big building owners, including the federal government, policymakers, federal, state and local governments, tenants, investors, is really going to help accelerate progress. So the more we can do, the more voices that are out there and the more collaboration across the supply chain, I think the faster we're going to see really transformative change.
Sarah, that's really great. Before we bring everybody together for a conversation, I do have a question for Sarah. If you can kind of go back to that last slide, that was just up there. Sarah, did you find that when we look at the demand shifting markets, when you would go, when Skanska would go to the suppliers and sort of try to figure out where to spec, based on the EPDs that were available, I guess, were there a lot of new materials, or was it just, new types of materials that you saw, or again, you were just kind of focused on the products and seeing which one had the lowest footprint?
So it's a little bit of both. And I will say very different regional experiences. So in markets like Seattle and Los Angeles, there were already on concrete, for instance, is already standard for the suppliers to develop those plant specific EPDs. So we were able to move right into just optimizing for carbon intensity. In other markets, it's a lot more outreach with suppliers kind of explaining like, what is an EPD? How much is it going to cost for you to make one? Why do we care? How are we going to use this? And so I think there's that piece. And then we do, in some of our places, we're getting into the point where we're engaging with that supplier and really trying to optimize the mix. So that's kind of getting to your point about different products. And we're also starting to think about this in terms of like MEP systems. And, this gets to the refrigerant point that came up earlier. So for a lot of our projects, we are starting with the structure just because that is where the biggest impact lies. But that over time, and I think with each project that we do in each of our markets, we're going to get to incorporate more and more of those different material categories and try to engage with those different suppliers too.
Great. Well, let's bring Leo and Sarah and Stacy and me all into little boxes in the screen. I don't know how we do this. I think we add folks. I don't know, Philip, if you can kind of add the four of us to the to it.
I'm seeing all of us right now.
Oh, you are? Okay, great.
Yeah.
Okay, great.
Yeah.
Oh, you know what? Then it's just my view. I've been doing this for 17 months. You would think that, okay, here we go. We're here. Okay. So my first question really is, I want to address data gaps, data issues. And I know that this is something that all of you are well-versed in. What are the data gaps when we look at the EPDs that are out there across products? Maybe I'll focus on Stacy to answer it first. What are the data gaps that are out there? And where and how can the federal government, is there a role for the federal government in addressing some of these data gaps?
Sure. Yeah. So we've done an assessment of EPD adoption actually for some of the policymakers that are looking at this. And so for concretes, even though we have, 35,000 mixed specific EPDs, it's really about 5% of the market in the US. So we have these regional pockets where we have really good data, and then a whole bunch of other smaller facilities that are not engaged in this yet. And that's really following private policymakers that are putting out these asks in major kind of urban markets. So for steel, on the other hand, we have almost 60% of all steel mills covered with facility-specific EPDs in the US. There's less of them, right? But we are seeing better. We're getting more and more of that adoption. What we really could use help with is the incentives for those smaller suppliers to have grants or some kind of subsidized programs to help them create and generate the EPDs. The education piece that Dawn mentioned is very important too. But some kind of subsidy or grant program that really helps to incentivize and spur generation of EPDs for concrete suppliers. And Leo could talk to this too. With the on-demand approach through the couple of suppliers that do that. It's not hundreds of thousands of dollars to do this at a concrete plant. It's tens of thousands, less than 30 sometimes to get that in place. So again, there's just money there that could help incentivize some of the smaller suppliers to make it more equitable, I think, and get a broader kind of regional adoption on the concrete side.
I'm hearing that there's a need for, there's a large gap in between the companies that have the capacity to do an EPD that might be larger and companies that may not have that capacity to get off the ground and to do the EPDs.
And then also urban versus more, I think, suburban or rural markets where you've got some of the large private owners pushing it and creating the market demand in kind of the urban cores. But there's a lot of places that pour a lot of concrete that aren't in those kind of locations.
To what extent, and maybe this is a question that Sarah and Leo can also speak to, is when, I'm just using concrete, for example, if it's poured on site, the equipment that is used to make that, I think we had a question earlier about electrification of that equipment. Is that a factor in how that EPD is communicated, or does the EPD again only go so far and then you have other ways to reduce the carbon footprint that are needed?
I would say that it's something that we should consider when we start to tackle the largest impacts first. So that equipment stage or transportation stage is, 0 to 5% of the overall emissions of making the concrete, for instance. So it's important, but the largest impacts for concrete is really in the generation of the cement and the concrete mix at the plant. So it's an important step, and it gets into emissions that are happening on site in terms of pollutants. So we should be looking at it, but it's not the largest impact when it comes to concrete or cement specifically. And Leo, I don't know if you want to jump in there, but.
No, I agree. Cement is the biggest driver in the concrete emission profile, and EPDs measure production emissions or scope 1 emissions the last component, whether you're, and we are, some of it, we're trying to run some of our ready mix trucks on biodiesel. We're trying to work with OEMs to develop electric cement tankers, or try to electrify our heavy duty equipment. Those won't necessarily show up in an EPD, but they're the right thing to do. And as a global leader in sustainable building materials, we view it as our responsibility to lead the way.
Sarah, do you have any thoughts on that?
On the owner side, I think I agree with what they both said, but I think that electrification of construction sites, I think, is going to be something that more cities are looking for over time. And so I think that demand from city leaderships, it's a local air pollution issue, and other things. So I think that there's a lot of, even if it's not the biggest slice of the pie, I think there's some important things we can do there too.
I do want to move to market uptake and sort of regional examples in just a moment here. But before we close out and on the data question, when we look at the earlier in the webinar, it came up that there are different ways that product category rules are done in Europe and how they're done in the United States. Where is the greatest need for harmonization of standards or certification? Because the reason I ask this question specifically is that sometimes if there's a lack of confusion around data in the market, that can actually be a barrier to procurement officials knowing kind of where and what to spec. To what extent is that an issue more broadly when we're looking at a range of materials with heavy embodied emissions?
So there's two areas that we're focused on helping with. One is the underlying data that's being used to do some of the process emission calculations. It's getting into the US LCI database and the sources of data and how transparent you are around that. We've built in some of that tracking into the EC3 versions of the EPDs to hopefully push that to being actually included, where you're pointing back to your actual data sources, and then creating inventory sets that a government could point to in terms of use these to create your EPDs. So there's some of that happening, and there's, I think, proposals to help fund some of that work and policies that are being developed now. And then I think the other one, I've lost my train of thought, around PCRs and standards. Again, if the federal government wanted to say, all concrete and steel used on federal projects needed to have EPDs, they could say, follow this PCR to create the EPD that we will use, that then enables fair comparisons because they're using the same requirements. And then pointing back to the same underlying data sets would be the other side of that I just mentioned. So there's a lot of work going on. There needs to be more discussions and funding, but I think also the data that we have, like when it comes to concrete here in the US, there's 2 suppliers of those EPDs. So the large crux of concrete EPDs being created are already using the same generator, the same PCR. So there's some of that already happening, enabling some of the work that we're doing now on the comparison side.
Thank you. That's helpful. I want to talk about market uptake and kind of a tipping point. So we talk about the role of the federal government. Leo, you mentioned the public works projects that that your company supplies to, and I think Sarah, I'm curious to get the perspective of Skanska, whether you think there are other peer companies that are asking the same things that Skanska is asking. But at what point are we at a tipping point? Because one of the things that we hear a lot is that lower carbon goods and services are going to cost more money. And what I'm hearing on the webinar today is that, balancing, quality and cost, there's still ways forward to procure lower carbon goods and services. But, maybe you can talk a little bit more about what does the federal government specifically, what actions would really create a wholesale market shift and a permanent market shift where companies are investing in lower carbon goods and services. And while we have the example of cement and concrete here, at least from the perspective of Stacy and Sarah, I'm also curious if you have insights into some of the other heavy materials.
Yeah, I'll jump in. I think, there is a group that's come together called Owners Carbon Action Network. And so it's a group of large building owners that are gathering, maybe once a month or every other week to talk about how can we share information? How can we make these asks in ways that sound familiar so that the suppliers aren't confused by, a slightly different request coming from 10 different angles. And so I think there is a lot of effort happening, especially among owners of large portfolios or just large developers, to be more consistent and to kind of start using some common templates and common language as we make those asks of suppliers. And so to me, I think that we are seeing the tipping points are happening really fast all over the place. And I think policy is a huge driver in that. So I think the reason that some our markets in LA and Seattle that we already can just move right into selecting for the low carbon options is in large part because of some policy implications that have been put in place before. But it is exciting to see, just as we talk with suppliers, some haven't heard of an EPD before, others are like, oh yes, this came up on like the last project that I bid on. And so I think that the federal government's role, I think, is just, it's such a big entity and in so many different areas. And this gets back to Stacey's point of, the regional variability in the APD availability. So yeah, I think there's exciting tipping points happening all the time.
Yeah, I mean, for us as a building supplier, we've started to see more and more jobs being in the specs requiring EPDs just to submit a bid, and that's exciting for us because we're at the forefront. We have the EPDs, but it's also sending the market signal to everyone else that they have to get it. I think to your earlier question, Marina, of like, what is a major tipping point? If the federal government required EPDs, that would be a big driver in the supply of data, in the market signal to create that competition for low carbon products. You're not going to want to have your product stack up against your neighbor's product. And I think it was Sarah who made the point of like, inertia is real. And oftentimes, EPDs have been around for 10 years, low carbon cements have been around for a long time. The adoption of them have been really slow because there hasn't been the right market signal to force their adoption. And absent that, folks are going to continue to do the cements and concretes of yesterday. I mean, it's the same recipe we've been using for 200 years.
And I think building upon that point, Leo, one thing that when we were talking kind of before the webinar, you'd mentioned that there are different recipes that are out there for different kinds of applications. And I'm wondering if there are any best practices in procurement language that any of the three of you are seeing that can also help to reduce the emissions. So when we think about the design build side, and the reason I'm asking these questions is because if there's harmonization and standardization, not just in the federal government, but if you also think about state and local governments coming alongside, where corporations are taking action, what does that do? And so if you have any best practices on what kind of procurement language that is sort of working, that'd be really great to hear.
Yeah, I think that's two questions, and if Sarah or Stacey want to jump in from their perspective, I'd welcome that. But I think there's one requirement to submit the EPD. I think that's the transparency piece. I think the larger question that you were getting to, Verena, in the conversation you and I were having is oftentimes we are able to work with the structural engineer to pick the specific blend of concrete needed. So whether it's an ultra high performance concrete, a Thermoflow that has energy efficiency perspective for data centers, or just a particular blend that uses fly ash or other material that's suitable for that project. I think one of the biggest drivers in embodied emissions is oftentimes over specification. So you might need, just, I don't want to say regular concrete, but you specify ultra high performance concrete and you end up using more than you need. And we'll, as the building material suppliers, have the expertise to tell you, hey, you're not building a skyscraper. You don't need that kind of concrete. I think Sarah had a wonderful example of, 6,000 PSI, 8,000 PSI. So different layers of the building use different strength capacities. But if you just come in and say, I want all of it at 8,000 PSI, you're going to be overusing cement and concrete.
I mean, what we've seen with projects that are doing this well is that they've moved from a prescriptive to performance-based specification for concrete, which is a change for structural engineers to not say that it's a maximum cement replacement or create these thresholds and kind of dictate what a supplier can do. So I use the analogy of baking a cake. I think concrete suppliers are like master cake bakers. They know the ingredients that they can use and shift out to create a lower carb cake that still has the same taste and the thick frosting that you want, that looks just like the high carb, high sugar cake. And you need to give them that freedom to do that work. And that's just a shift in how we think about specifying concrete.
I'm going to have to borrow that analogy, by the way.
Yeah, that's an analogy. Are there lessons that you've seen? If you have mentioned Canada and Europe, are there lessons that you've seen in other markets that have really created shifts in other markets? And what can we learn from those?
I mentioned Canada. I think the government of Canada requiring the use of low carbon cement was a fundamental shift in that market, and we see some of that cement coming into the U.S. and the Great Lakes, some of it coming into the Seattle market. I think in Europe, Stacy hit it on, and something that we would love for the U.S. to adopt is more of that performance-based specification. Come to us, tell us this is what you're building, this is what you need, and let us give you the product that meets that performance level. Don't come and tell us, give me this product. I mean, we'll sell it to you, but it might not be the best product for your design.
Yeah, I guess for me, it's less about what's happening in other countries and more about best practices sharing between our own projects in different markets, because there's such different things happening. And, going back to the structural engineer point, I think there's some structural engineers that have been thinking about this for a while and have really thought about how to write performance specs in a good way. And so some of it's importing some of that knowledge from a Houston project to a Boston project and kind of doing that cross-pollination that's going to help the projects in different markets kind of come along, because I think it really is about that collaboration. And we always use the same contractor, so we've got Skanska, the contractor side of our company, in-house, and so we also have that benefit of being able to share lessons learned across markets. So I think that's going to be super important going forward.
That's great. I'm realizing, I could spend all day here, but I'm realizing we only have a couple minutes left on the webinar. But I did want to, if we have time, I'll ask two questions, but I'll ask one. There's been, attention and focus on the transparency piece, on the transparency and disclosure as a first building block of getting the broader reductions in embodied emissions down. And I think there's often, at least for me, I want to sort of run to the solution first. Can each of you provide a perspective on why transparency and disclosure is so important as that first building block? And maybe I'll start with Stacy.
So I think you have to have that before you can actually do comparisons or reductions. And I think what also is really important as suppliers are asked and then engage in transparency of their products, they actually learn about their products and where the impacts are. And that's what can lead them to actually understand where they can make reductions and come up with lower carbon options. But if you don't have that level playing field of disclosure, it's really hard to create that kind of competition between suppliers. You need to have that even playing field of disclosure and transparency first. But again, I think the bigger uptick is the suppliers doing the work to create these data sources, then say, gosh, my biggest emissions factor for my product is X. I need to go find a lower carbon option for that ingredient or that process. And that's another benefit of engaging them in that transparency process.
Great, that's very helpful. Who wants to go next?
I can jump in.
Okay.
Yeah, so I think echo what Stacy said. I think, I think that we can have some aha moments in the procurement process where you typically would just think, price and schedule and performance and, just our normal things that we would level the bids with. And if you just add carbon intensity, the aha could be that maybe it's not more expensive. Maybe you worried that it was going to be this huge cost premium. And certainly as we get to trying to get to carbon neutral, there's going to be cost impacts probably, but in this first bite at the apple, there's so much we can do with just the transparency. And then I think the idea of transparency too, then encourages suppliers it builds on that innovation spirit. So they want to be the low carbon bidder. And so how can we get that transparency to make them feel that even more?
That's really helpful. I guess, Leo, you get the last statement on the webinar. What are your thoughts on transparency and disclosure and from the perspective of a company?
No, Sarah's dead on. I mean, we love the competition. We love that spirit of innovation. And I want to stack up our EPDs versus someone else in my region. And if I don't have the lowest one, I need to figure out how to get the lowest one. And that's going to drive the innovation for the market. And I think the last thing that I'll close with is that price perspective. Oftentimes, and yes, if the 50, 60, 70% or beyond carbon emission reduction concrete blends might be a little bit more expensive and from my perspective, that's not a problem. Then again, I'm not an owner developer, so more of a problem for Sarah and her team. But carbon cemented concrete are, a small percentage of an overall cost build. So where you can reduce your embodied carbon, even though it's a little bit more expensive, you can probably make it up in other parts of your construction process. But at the 30% level reduction, in some markets, they're priced equally. We can deliver them at the same performance level, at the same price, yet the market won't adopt it. And I think getting that transparency and getting that competition going is key to helping the adoption of low carbon cemented concretes.
So what I'm hearing is transparency is needed to spur aha moments, innovation, competition. The procurement is the driver to be asking companies to do it in the first place. And there are opportunities for even more innovation along the way. Well, I could spend all day, but we don't have it. So thank you so much to Sarah, Stacy, and Leo, and Don. I know you've been on listening in, and we appreciate your earlier comments. And thanks to all who joined, and we'll probably continue this conversation at some other point as well. So thanks so much.
Thank you.